All right, everybody, we have time for some brief questions and answers before we've all got to exit the room so the hotel can put the lunch setting up. So my requirement for questions is you cannot state something and pretend that's a question. So we're going to play Jeopardy rules. Whatever you say must be phrased in the form of a question. So John Nordert has the microphone. So let's have some good questions here.
A question, Dr. Idso. What about Norman Borlaug?
Come to my talk, the next talk that I'm giving right after lunch, and I'm actually going to provide a few quotes from him, a wonderful researcher who noted that there's a food crisis looming on the horizon, and I will share with you further information to show how the rise in CO2 will help to meet the coming food shortage. So thank you for the teaser.
Dr. Idso, what do you say, it's Julia Morris from Reason Foundation, what do you say to alarmists who claim that there is going to be a limit to the effective benefits to carbon dioxide fertilization going forward, and then there'll be offsetting effects of rising temperature?
Great question. I guess I could first ask them where's their proof, probably found in models, so to speak. But when you look at the data, a lot of studies have looked at various concentrations of CO2 in the future and how that will affect plants. And so the range is most of the studies on CO2 enrichment are done for a nominal doubling of CO2. So they'll take it from anywhere from 500 to 800 parts per million is where that range is done in. However, several studies have gone beyond that range. It was referenced earlier today that the Dutch greenhouses use a concentration of about 1,000 parts per million. And many of the studies that go up to 1,000, 2,000 parts per million see a linear growth response over that range. So if we burned all the fossil fuels that we could get access to right now, it's my understanding that it would only raise the CO2 content of the air somewhere between 1,000 and 2,000 parts per million. So for that entire range of burning all the fossil fuels, we will continue to see benefits for an increase in CO2. With respect to temperature, what we find here is that plants actually photosynthesize better under higher temperatures. So they're built for that. So it raises their level of optimum photosynthesis by several degrees centigrade at higher CO2 concentrations. And so, and in fact, it raises it far beyond the amount that's predicted from warming. So it's not a problem. And in fact, if it was warmer, it would be more helpful to the plants. We'd actually experience greater increases in photosynthesis and biomass.
Becky Norton Dunlop with the Heritage Foundation back here. Thank you guys very much for your fabulous presentations. My question is, other than President Trump, what individual or position or group of individuals in this current administration do you think would be most important to hear your presentation?
U.S. Congress, for starters.
I think from the agricultural perspective, the USDA would obviously be an important place. Department of Interior as well.
Department of Energy, yeah. EPA.
Yeah. All
Ivanka
of them.
Trump, all the above.
Yeah. And that's really too the message that CO2 is a benefit is one that's largely ignored. You all know about it. You've been coming to these conferences, but outside this room, very few people know this benefit. It's not taught like it was back in 5th grade science class for you and I when we learned back then that CO2 is plant food. That's all ignored now. It's that they're taught now in 5th grade science class that CO2 is a pollutant and that we need to reduce it.
Also, that abundant, affordable, reliable energy is good. It's not bad. I think that is something that needs to be repeated over and over and over to all elected representatives, bureaucrats, the general public, because as Craig indicated, it's been turned around that people think, energy development, economic development is something evil you have to somehow suppress, and it's just the opposite. If we want a healthy environment, if we want to alleviate poverty, etc., you need vast quantities of fossil energy.
It is actually the best argument against universal education, the way it is taught here. There isn't a single... I've come to the conclusion that virtually everybody must have missed that class in biology that said carbon dioxide is plant food, because it is news to everybody. I don't know how you get around that, but it really is a very poor, it's an argument against the education system as we have it.
Virtually every greenhouse in the world pumps carbon dioxide in to facilitate plant growth.
Question back here.
Yes, Jerry Baruffi from Seattle. You showed one slide about global warming of the oceans, and how does that CO2 infiltrate the oceans, and what kind of effect will that have?
I don't think any of us showed a slide of that, but I'll comment on it. The oceans are absorbing CO2, and it's absorbed at different rates, different time scales. And so there's the concern that it might cause ocean acidification. That's a term you're all familiar with. But in fact, the oceans are basic. The pH is roughly a value of about 8.1. 7 is neutral. And there are fairly good reasonable estimates that the pH will drop a little bit, maybe 0.1 to 0.3 pH. But in all of the research I've looked at, and I've got a lot of this you can look at on my CO2 Science website, if you go to the subject index under ocean acidification, you can see that pH varies over a daily scale, large amounts, far larger than the amounts that are expected to predict or expected to occur over the next century. And organisms can adapt, and there's lots of issues with the studies that look at the negative results that are coming out there. So my conclusion and my estimation of reading all that research is that it won't be a problem, that there'll be enough time for organisms to adapt, and some will actually benefit from the extra CO2.
And there is one more factor that needs to be considered, and that is that corals and other organisms that live in the ocean, they've been there for eons. They've seen different carbon dioxide levels throughout. They've experienced it before, and that's what has allowed them to, they've evolved through that, and there is more than a good likelihood that they'll be able to deal with it. And one of the things that we always forget is that we think that what's happening today has never happened before. But if it's happened previously, you have to believe that there is a mechanism that has allowed organisms that have lived through that to adapt. That's how they got here. They got through that before, and they'll get through it again. We keep forgetting that. And that's the other thing that seems to have been lost. Most of these people seem to have forgotten about evolution. And if you have evolved through that, there's a good likelihood that if it comes again, we will be able to deal with it. And another thing that we need to remember is that if it warms, the gases in the ocean there'll be outgassing, and there will be some emissions of CO. So there's an equilibrium level that has to be figured out. That has to do with the chemistry and the temperature and a bunch of other things. It's not as clear as it looks. In fact, virtually every study that they seem to have done on ocean acidification with real organisms that have looked at acidification through changes in the carbon dioxide pressures indicate that there's a lot of evolutionary potential right there.
Yep.
It used to be that they used to do this by subjecting them to acidification via hydrogen chloride. That's not the way nature would do it. It's crazy, actually. I'm surprised that they even got published, but you know what? They did.
Okay.
Hi, I'm Penny Starr with Breitbart News. So people are always making models about the future and what's going to happen with climate change, and they talk about the hottest years being just recently. But isn't it true that if you look back, even on government websites like NOAA, that the hottest and most extreme weather, droughts and glaciers all happened, way before man drove an SUV, that's for sure.
Yeah, that's correct. Climate's been changing on multiple timescales due to natural causes. And we can point to many different time periods that were warmer than the present. The most obvious is the most recent medieval warm period, about 1,000 years ago, when temperatures were about anywhere from a half to a degree Celsius warmer than they are presently. Same thing if you go back another about 1,000, 1,500 years, the Roman warm period, the Minoan warm period, and then the Holocene warm period. So there's multiple periods where it's been warmer, and for much longer periods of time, like the Holocene, for example, and the Greenland ice sheet didn't melt away during that period of time, and we all survived. Nature didn't just disappear. So, yeah, there's many periods, many analogs we can point to in the past.
Ben Denniston, 21st Century Science and Technology. For Dr. Idso, I've seen some studies showing satellite measurements attempting to measure the increased greening net primary production. I'm wondering what you think about the validity of those methods. And related to that, I've also heard that particularly in desert areas is where you actually have some of the most significant increase because there's more efficient use of water, which I think is also an interesting aspect. So if you could comment on those.
Yeah, absolutely. So the satellite data are very good. They're not influenced by tinkering down here with the data sets like we get with the surface temperature data set and so forth, but they're very reliable. And what we see, since they've been measuring, 1982 is usually the start point in most studies. Since 1982, we see anywhere from a 6 to a 15% increase in productivity. So that's a phenomenal increase over that period of time, especially when you consider, I love to say this, the climate alarmists, they'll tell you, the Earth's going to hell in a handbasket, right? It's the warmest it's ever been. Forest fires, pests, in insect outbreaks, deforestation, war, all those things that have happened. I mean, if you listen to that, the Earth should be in the worst state, since mankind or society's been here. But in fact, looking at these satellite data and then also combined with some land data, we see that actually it's better off than it's ever been since we began measuring. Over the last 50 years, for example, the carbon uptake has pretty much doubled in the globe, over the land and the oceans. And then you're right also about the deserts. We see a lot of the greening, we call it the greening of the earth, this CO2 fertilization. We find it occurring in these deserts. Why? Because one of the great benefits of higher CO2 concentrations is that it increases a plant's water use efficiency. So at higher CO2 concentrations, their stomatal pores are not as open. They lose less water to the air by transpiration and evaporation. So they need less water to produce the same amount of tissue. And so you can find that in these situations where you have water limiting lands and also hot temperatures, as I talked about also, that higher CO2 helps alleviate that stress and perform better. That you can actually see this great greening taking place already in some of these deserts, and there have been studies looking at the Sahel, for example, that have documented this.
In other words, what we should be trying to facilitate is the greater use of fossil fuels, more CO2 rather than less.
Andy May, a retired petrophysicist. Dr. Idso, phytoplankton in many ways is kind of the base source of life in the oceans. How does CO2 affect the amount of phytoplankton, and is that beneficial, or do you know?
Yeah, so we've reviewed a few studies that have looked at that, phytoplankton, on our website. And again, I don't have the studies in front of me to remember, but go to our section under our subject index under ocean acidification, and there's a section under phytoplankton that looks at several studies at many different types of phytoplankton, like coccolithophores, for example. There's been studies to show that they've been increasing. They'll take these cores and look at their size and so forth over time, that over the last 250 years there's been like a 40% increase in coccolithophore abundance, and also I think size as well. So a lot of them do respond positively as well. Yeah. Mm-hmm.
Alex Rechnik, NPR Associates. Dr. Idso, I have a question about a potential contradiction. You mentioned that CO2 is a trace gas, and yet it has huge beneficial results. On the temperature side, we've argued that because it's such a trace gas, it couldn't possibly have an effect on temperature. Can you resolve that discrepancy?
I guess I'm not quite sure what discrepancy how it's a discrepancy there. Maybe you could elaborate a little bit more so I understand your question.
Sure. So the difference between 350 ppm, 400 ppm is small.
Right.
And the physical scientists on earlier panel today have argued that from a common sense perspective, that couldn't possibly have an effect on global temperatures because it's such a small change in a trace gas concentration.
Right.
Why is that argument not true for CO2 effect on plants?
Well, you're talking about two different things. As a trace gas, they're talking about the radiative effects, how it affects the climate, how more CO2 in the atmosphere will create a larger blanket as an analog to trap more of that radiation trying to escape the Earth out of the atmosphere. So it does have that effect, and one can debate, to what effect that will cause the climate. But then it's a totally different, point of view looking at how it's going to affect biology. I mean, there's really two sides of this coin here. You have, when you raise the CO2 concentration, there's the climate aspect, but then there's the biology aspect, which is a different path. So the biology aspect, as we talked about, CO2 is food for plants. It's a primary raw material that's utilized during that process of photosynthesis. So that's why, you take a primary material in at one end of the production process, and if you increase that primary raw material, you tend to end up with a larger amount on the other end. In this instance, you're going to have greater productivity of the plants. So they can continue independently on these two different paths. You can have changes to the climate and the biology.
18.5% of a human body is carbon. Despite the fact that there's only 350 or 400 ppm, 400 now, ppm of CO2. Because what happens is we need that. It's like when you get micronutrients, those come in even tinier quantities than carbon dioxide. It's a different issue.
Getting away from the issue of carbon as a pollutant, the endangerment finding is what EPA is going to have. The endangerment finding is what EPA is going to have to be dealing with. I'm surprised that this information hasn't come to EPA in comments, and it certainly should be coming in comments. So
it has. I sent this material on way back when, so it's been ignored. Like I said, selective.
And hopefully the new administration is not going to be ignoring it.
Hope not. That's for sure.
I think you've got a couple of people there.
Yeah, we've got a question in the back that's going to be
There's
getting answered. All right, so we've got about 8 more minutes for Q&A. So this is a long
Question
Q&A.
to Craig Idso. Do you have any data on the decrease in water use with increasing CO2?
Yes. So you can look at what's called intrinsic water use efficiency. It's a measure of these plants over time. And scientists will go and they'll core trees that have been long-living trees like bristlecone pine or various other kinds. And they've done that all across the globe. And you can plot and see that for the longest time period before the Industrial Revolution, an intrinsic water use efficiency line is pretty flat. But then over the last 100 to 150 years, there's a nice increase that dovetails perfectly as we would expect with the increase in CO2.
Probably to Dr. Idso, though, any of you, I'm interested in comments. Is there like a comfort zone? Say you could release unlimited amounts of CO2. Is there like a comfort zone, like 1500 ppm, 2000 ppm, something where beyond which you think potentially the disadvantages might start kicking in?
Yeah, Walt Cunningham talked a little bit about it this morning about classrooms. You can get 1 to 2,000 parts per million in a classroom. I've done a lot of studies like that as well, where a normal classroom of 30, 40 students can raise the part per million to about 1,500 part per million, as long as there's not a lot of air exchange within the outside. But it's really not a problem for human health until you get to values of about 15 to 30,000. About 30,000, you'll start to feel some nausea and dizziness. 30,000 parts per million. So, there will never ever be a direct, negative to human health as the CO2 concentrations rise. As far as optimum, I would say, any range that we can raise it, because we talked about if we burned all the fossil fuels, we're only going to get to 1,500, maybe 2,000 parts per million at the most, and we'll see great increases, almost linear increases in crop yields over that range.
Yeah, Walt Cunningham this morning mentioned that in the submarines it's up to 8,000. And International Space Station it's up to 10,000 with no ill effects on inhabitants. So
This will be the last question.
Again, for Dr. Idso, and wanted to first of all say you do great work, and we really appreciate the work you do. Rich Trupack. So most of the time when the other side argues against those of us who are realists, 90% of the time it's you're on the pay of name the oil company, right? But every once in a while you do get a technical argument from the other side. What is when that rarely happens? What is the technical argument that they try to push back with?
A lot of that technical argument is what was brought up with one of the very first questions about, well, the temperatures are going to get too hot and plants won't be able to survive. And again, that's just not true. That's been documented by a fair amount of research. It's very solid research that as the temperatures rise, the plants will actually photosynthesize a little better. And that will allow them, you won't have the extinction of species. So that's where they're really coming, that temperatures are going to rise too fast, too furious, that these plants and animals won't be able to move quick enough to avoid extinction. But you see that that's actually not going to be the case, that they can match that temperature increase and go beyond it. So.
Yeah, the question I've been getting for 2 decades is why don't we just get rid of fossil fuels and power everything with renewables, wind and solar? And I've been trying to answer that question and without too much favorable results, unfortunately. People just don't get it.